Good evening, Era. It's a pleasure to welcome you all to the sixth workshop of TesserX, an initiative under the Axis 2025 and Sri Lanka's first ever school level ideathon of its kind, proudly organized by the Royal College Computer Society in collaboration with OREPA. TesserX has continued to grow as a space for young innovators to explore and thrive, and today's session marks another important step forward. As teams continue to move through the ideathon, it's time to start thinking beyond just coding and creativity and look at something just as important, making your ideas practical, sustainable, and ready for the real world. This evening's focus is on cloud and artificial intelligence, a key step in turning a great idea into something functional, fundable, and future ready. Learning how to present your solution with a solid business foundation can make all the difference when it comes to standing out. We are truly honored to have Mr. Neranjan Dissanayake, the Chief Executive Officer of Just In Time Group, with us today. With his experience in innovation strategy and data-driven decision making, he'll be guiding you through the essentials of building a strong, clear, and impactful plan. Make the most of this opportunity, ask questions, get involved, and take in as much as you can. What you learn here won't just help you in TesserX. It will go a long way in whatever you choose to do next. Let's keep the momentum going and have a great session ahead. Thank you.
Thank you very much for the introduction and everything. So let me share my screen quickly. Wait. But can you all see the screen properly?
Yes, we can see it. Yes.
Right, excellent. Right, good evening again, everyone. So I'll try to keep the session at a very high level. I'm not going to deep dive into all the technical areas. I just wanted to give you all a good understanding about the things that we need to consider when we are developing cloud native applications. So the first part would cover the cloud aspect of it, and the second part would cover the AI aspect of it. And I'm sure most of you have already gone through so I mean, like implementing applications in cloud environments, or maybe trying out various APIs and other AI models out there as open source resources. So I'll go through the session. If you have any questions, just post them in the chat, and I'll take the questions later and provide you the answers. So our organizing team will be able to share the answers with you later. Because like you all have, I think, school tomorrow, Monday morning, so you need to dress properly and get prepared for school as well. So I'm not going to have a lengthy session. I'll try to keep it brief at a very high level. Yeah. Right. So for some reason, the slides are changing. Correct. Okay, so this is the high-level overview of the session. First, we'll try to understand what cloud is and the basic concepts, the architectures, the advantages, disadvantages, and basic fundamentals, and what a cloud-native application is. Then I'll introduce you to some developer tools. We will not do any hands-on work today because of the time limitation. But I'll introduce you to some of the concepts and tools that we use in cloud application development. And because like you will not be able to use all the professional tools, so you need to get access to some of the easy to find tools, so maybe free tools out there. And I'll also talk about some of the best practices that you can have when implementing cloud native applications. Right. So what's cloud? I mean, even though we use the word cloud, so everything actually ends up somewhere at a server or a router or a switch, right? So there are physical hardware that we need to have in data centers. Even we need to go with cloud computing. So we all know about AWS platforms, Azure platforms, or Google platforms. They all have massive server farms and data centers in multiple locations in world around the globe. And so they have different zones, and I mean, like huge data centers. So everything that we do in our cloud environments end up in those data centers. So if you have a basic internet connection, then you can get access to AWS or Azure or Google. So when you are developing your applications for this competition, so you can actually use most of the free versions out there. I mean, for most of the services, AWS, Azure, and Google gives you, you don't have to pay. But depending on your application architecture and what you need to actually achieve, you may have to pay for certain things. But most of the resources can be um, taken as free resources. So if you have internet connection, go to AWS, go to Azure, go to a Google Cloud, create a account, and start experimenting. So this free account will give you access to a lot of resources, storage, virtual machines, databases, development platforms. I mean, to large DevOps environments. If you need to develop machine learning models, then you can get access to those as well. Then if you want to implement certain security features, then you can get all those security solutions implemented as well. So routing, switching, everything, DNS servers, website hosting, everything can be done in those platforms, right? So then, I mean, in earlier days, in early 2000s, we had virtual machines. We did not have these cloud platforms or cloud services. We had virtual machines. I mean, even before that, we didn't even have virtual machines. I don't know whether you have heard of those things. So we only had the physical servers. So one physical server, one operating system, one application. That was it. And after that, the concept of virtual machines came into play. And with virtual machines, we could use a hypervisor like VMware ESXi. And within that physical server, we could have multiple virtual machines. So I'm sure most of you have used VMware Workstation, the desktop version of that. And by installing that in your laptop or home PC, you can have multiple virtual machines on your physical server or laptop or PC. Then after a few years, we had containers. I mean, so in virtual machines, you implement operating system and you implement one application, one large application. So in a single server, you can actually host multiple applications and share the resources. Then after that, we had containers. So I'm sure you have heard about Docker. We mostly used Docker containers in development environments and production environments. So in a container, I mean, I'll speak about it later as well. So in containers, actually, without using a hypervisor, you can implement Docker platform, and using container management application like Kubernetes or something, you can, I mean, utilize resources in a better way, right? By using containers. So I'll speak about it in the coming slides. Then we have this serverless environment. So you know that when you are developing a application, when you code, you sometimes call functions. So the serverless concept is similar. So you don't want to have a dedicated server or a machine or a resource. You can just call a function and get something done. And after you get that thing done, you can release the resources. I mean, you don't even need to know anything about this hardware or how the resources are utilized in cloud environments in AWS Lambda or something. You can actually use a function to get something done when and if needed. So you don't need to dedicate resources. Then I mean, it's very scalable. If the requirement goes up, then you can actually use multiple functions or instances of functions, and you can scale it up very easily. And now actually we have these service meshes as well with microservices architecture. I mean, I'll speak about microservices architecture in coming slides. So you connect different microservices using a service mesh, right? So microservices can communicate and work with other microservices using a service mesh. It's a infrastructure layer for different microservice instances to communicate. Right. So when it comes to cloud, so we have three main concepts. We have public cloud. So public cloud is something like AWS, Azure, or Google. Or in Sri Lanka, we have Dialog, we have SLT, we have Oracle Cloud. So these, I mean, you can get the service after paying a certain amount. You can pay monthly or yearly, or maybe some for certain things you can pay upfront as well. Very scalable. Everyone has access. I mean, rich or poor or wherever you are, you can get access to these public clouds. And they will give you unlimited storage, unlimited computing power, and very efficient in cost as well, because you are you are sharing the resources, and very scalable. You can scale whenever you want. Right? Then you have private clouds. A private cloud is the data center that you have in your own environment. Let's say if we take a enterprise enterprise environment, you have a data center in your office building or maybe in a separate building. It's managed by you. You have full control, full access. Other people can't get access to it. You are managing it. Cost is very high because you have to purchase all the hardware upfront. And flexibility is, flexibility in the sense that you can control and decide what you want. What's the hardware type you want, from which vendor you are going to buy it, and what you are going to install. No sharing. Security is high. Security is very high. If you configure it properly, you can customize it as you want, but the overhead is very high. Overhead means the upfront cost that you have to bear to implement the data center. Then you have hybrid cloud, a mix of both the versions. I mean, you can get the better sides of both the versions, advantages of both the instances of public cloud and private cloud. So most of the people have their main data center in their own environment, and maybe disaster recovery site in public cloud, or maybe have a smaller portion of the most critical applications in the environment, and maybe have everything else in the cloud. Different implementation methodologies. Very flexible. Security is very high. You can scale as you want, very cost efficient. And so both good sides of both the instances. And so these are the main three clouds that we have. And there's something called community cloud as well. I mean, if let's say certain customers who have different uh, who have similar interests, or maybe in a similar business, they can all get together and form their own cloud. I mean, all the universities in Sri Lanka can actually get together and maybe form a cloud for universities only. Then it would be a community cloud. It's not widely used, but used in certain applications, like in certain government and defense environment in certain countries. This is the three basic models of cloud environments. Then you have different implementation methodologies as well. The first one is very simple: infrastructure as a service, right? So you go to AWS and you spin off a virtual machine. That's the infrastructure that you get, right? And you have access up to the OS level. So you can decide the OS operating system that you are going to have, Windows or Linux or Solaris or whatever, and what are the applications you are going to run, data, middleware, everything you can decide. The cloud provider will only give you the infrastructure. Then you have platform as a service. So if you go to a cloud service provider and get a database, then you get the platform, right? The cloud service provider will not give you access to the operating system or database application or anything, right? They will only give you the application in the sense like the integration part of it. You will only get access to the database instance that you get, right? Then you have software as a service. So if you are using Gmail, then Gmail is a software as a service application. if you are using O365, Microsoft O365, then you only get the software, right? You don't have access to anything else. The vendor will manage everything and give you access just for the application. So when you are developing your own application for this competition, you might need to get infrastructure as service in certain scenarios, platform as service in certain scenarios, and maybe if you are integrating the application with certain third-party service providers, then SaaS or software as service might be an option for you as well. So different methodologies of getting services from cloud environments. So I spoke about certain advantages already. You can save cost if you do it properly, and you can lose money as well if you do not have a good idea about what you are doing. But since you are actually paying monthly mostly, you can save cost. The overhead is very minimal. I mean, you don't have to buy hardware upfront. The human resource requirement would be less, and time consumption to get something done will be very less, because like if you actually want to order hardware, if you order a server, it will take at least 6 to 8 weeks for that server to be delivered. But in cloud, 1 minute you can get whatever the server you want. It's very easy. So, but if you don't have a proper control on budgeting, then you can lose money. High speed, very easy. Whatever the service you want, whatever the application you want, 1, 2 minutes you can get it up and running. Security, there are two sides of it. Cloud service providers will give you all the security solutions, but you need to know what security controls and security products you want to have in your environment. Whether you need endpoint security for your machine, or whether you need a firewall, whether you need advanced denial of service protection, or whether you need a web application firewall. So you need to know what you have to implement. But if you do it right, then security is usually high. Flexible, like you have the flexibility to choose what you want. Uh, I mean, you can. Let's say if you order hardware device, if you don't like it, then you can't return it basically. But in cloud, if you don't like something, then you can close it down, shut it down, then go with another application or another server or whatever. Flexibility is very high. Mobility high, because you can transfer between environments, transfer between applications, transfer between platforms very high, and you can actually access the resources from anywhere. Wherever you are, you can access your cloud instances very easily. Then insights, cloud environments usually provide very good insights about the environment that you have. Reporting, monitoring becomes very easy. Increased collaboration, integrating with other service providers through APIs or other means becomes very easy. I mean, if you have on-prem data centers, then you have to allow access in and out to all the other service providers. But in cloud, just an integration of API mostly, and very easy. Quality control. So I will not deep dive into these things. Quality control becomes easy as well. Disaster recovery. If you have your disaster DR site means like you have your main data center. Then if something happens to your main data center, then you should have a backup plan, right? That's what we call by disaster recovery. So that backup environment, if it's in cloud, then you can actually, uh, if the primary site fails, then you can cut over to your disaster recovery site very easily within maybe seconds without having a big downtime. And anyone can create disaster recovery site very easily without much cost in the cloud environment. Then data loss prevention. Cloud environments are usually very secure if you go with the proper service provider. Then the chances of losing your data becomes low. And the cloud service providers will update all your software depending on what service you get. I mean, infrastructure as service, platform as service, and software as service. Depending on the environment you get, cloud service providers will provide automatic updates, vulnerability, like patch updates, everything. So life becomes very easy. Competitive edge becomes very high. For businesses, if they are using cloud, they can become very, very competitive because of the flexibility, scalability, and cost savings they have. Sustainability is usually high because you are sharing resources, and because you are sharing resources, the hardware usage and electricity use, like power consumption and everything becomes less because you are sharing things. And rather than multiple people having different environments, the sustainability becomes high. Scalability I spoke about. So these are the advantages. And some of the advantages I mentioned before could become risks as well. If you don't configure security properly, then it becomes a risk. And so I'll share the deck with you so you can go through these things. And all the advantages, if you don't manage properly, could become risk and lead to unwanted and undesired circumstances. And cloud environments change very, very fast. And if you are not updated, if you don't keep a close eye, then your life would become very hard. Right. So these are some additional slides for your reference. So this slide you need to focus on because since you are developing, so you are going to develop cloud native applications, you need to secure them properly. And make sure that you apply the right level of security controls. Maybe for your prototype application that you are developing, you may not be able to apply all the security controls because of the cost and everything, but at least in your design, in your architecture, make sure that you include these security controls properly, right? So let's say if you are developing an application which deals with personal data. What's personal data? So my name. So if you take a human being, they have personal data, their name, their age, their mobile number, their email address, their home address, their blood type, health records, bank account details, passport number, ID number. There are many, many things which can be considered as personal data. So if your application actually deals with personal data, then you need to have high security controls and make sure that your architecture or the design has those security controls, even if you do not deploy them actually in the cloud environment due to certain limitations. And if you are allowing access to people, then identity and access management. Which people get access to the application at which level? You call them authentication, authorization, and accounting as well. How are you going to authenticate? Is it based on your biometric data or based on password, based on OTP? And when I log in, what's the level of access I will have? What can I do within that application? Administrators will have different levels of access, and users will have different levels of access, and there could be different user categories as well. So make sure that you have these controls implemented properly. And APIs. So if you want to work with other third-party service providers, if you want to call other services from your application, then you may need to integrate that with APIs. And these APIs should be secure. They should have proper authentication, they should have proper encryption, and they should have proper data access levels defined to make sure these APIs work properly and they are properly secured. System vulnerabilities. So if you are using open source libraries or maybe other open source applications or operating systems or anything, make sure that they are properly patched and vulnerabilities are properly scanned and addressed. That needs to be done. Then account or service hijacking, maybe this might not be applicable for your environment, but sometimes hackers can actually get access to your accounts very easily. So since you have one administrator account for your cloud environment, make sure that you secure it properly. Or if there are different users logging in to your application, make sure that you have proper passwords, OTPs, so two-factor authentications. I mean, when you log into a bank account, you get a OTP to your phone. That's two-factor authentication. So make sure that you have those kind of controls as well. So insider threats may not be applicable for you unless one of your team members actually decide to do something nasty. So usually in private organizations, so maybe government organizations as well, people become disgruntled with their work environment. And sometimes people become stupid in certain instances as well. And some people do nasty actions knowingly, some people do those things unknowingly. But a person who has access to certain resources can knowingly or unknowingly help hackers to get data from environments, right? So that's called insider threats. Advanced persistent threats. Now, hackers actually are not the people you see in movies. They are well dressed. They are very intelligent, well funded. They have money, and governments and private organizations help them. Terrorists help them. So if they want to actually get into an environment or hack an application or a company or something, they work on that for multiple years. It's not just you take the laptop out, you try something, and you hack into environment. Sometimes there are instances in the world to hack into certain banks and all. They actually work for multiple years, right? That's why we call them advanced persistent threats. They are very, very persistent, and so you need to have controls against those as well. If you have any idea to scale the prototype application you have. Data loss prevention, make sure that you have controls for that to stop your data being leaked. So I don't know whether you heard about certain government website hacks and everything, and there was an attack in Cargill's bank as well a few weeks back, and people got access to the data. It's a very high, it's a very critical incident. People can lose reputation, lose data. So your design should have, even though, I'm repeating again, even though you do not implement them, make sure that your architecture has those components. So when, I don't know how the marks are given, but when your application is being evaluated, I'm sure they will focus on these security controls as well. Then malware, viruses, Trojans, worms, etc. So people can inject malware into your environment very easily. Then abuse of cloud services, overusage of cloud services, and so maybe someone can hack into an environment and turn on an unwanted service, and you will have to go through a financial loss in that way. Then the denial of service attacks. Let's say if someone wants to make a service down, if someone wants to make a website down, then what they do is they get people or maybe bots around the world to start communicating with that application or website. Let's say if my application only has capacity to serve 1,000 people, and if I am getting requests from 10,000 people at the same time, then my application will not be able to serve anyone. Then that application will maybe shut down, or maybe people will not get access to that site, or the desired usage can't be achieved. That we call in very simple terms denial of service attacks. So if you know these hacker groups, there are multiple hacker groups in the world. Hundreds and thousands of hacking groups. So they use these kind of things to attack websites and applications and other government services or private services to take things down. Then other things are not relevant for you, but make sure that you address all the security concerns in your architectural design. Right. So, what is cloud native? Very simple. Nothing big. The name actually has the definition as well. Cloud native means you are developing your application in a cloud environment, right? Using only cloud computing. So your design principles, your design ideas, your architectures will depend on the cloud environment that you choose. So identify what you are going to do, what your objectives are. I mean, I think you have done a session for business planning. So when you are developing an application, that application should solve a business objective. A business application should provide an answer to a practical, I mean, like, sorry, not practical, a real life issue. You should try to solve something. So if your application doesn't solve something, then, I mean, the purpose of developing that application is lost. So you should address a real life issue. I mean, I'm sure you have created problem statements. So your problem statement should have the issue or the problem that you are going to solve. And depending on that problem, you have to design the application architecture, right? And design the application architecture, you have to identify the requirements and the design ideas and everything. And depending on that, you can decide which cloud platform you are going to use. AWS or Azure or Google or any other cloud. I mean, most of these things are very similar. They all provide uh, similar things, but depending on your experience, depending on your skill, depending on your knowledgeable, right? So you have to decide what platform you are going to use. And some platforms give certain things free, and in the other service provider, that the free that thing can be a costly one. So pay attention to that and decide the cloud vendor you are going to use. Then cloud native applications are based on microservices architectures. So initially I believe that you will only be developing a prototype, but if you are selected for the final round, so maybe if you win, then maybe you will get a chance to expand that application. Maybe certain companies can ask you to come and develop this application. You can actually go for a startup as well if you really need. And if you have a brilliant problem solving application, then companies will sponsor you, companies will invest on you. And when you are developing this application, keep that idea in mind, what you are going to do in future, right? So come up with a brilliant problem statement, and keep expansion in mind. And when you have expansion in mind, your design ideas and your architecture will cover that as well. Then if you want to expand the application in future, then you need to go ahead with the microservices architecture. So earlier applications were monolithic. That means one chunk of code, huge codes, which are tightly coupled. But now we have microservices architectures, different small services working together to give a service to a customer. We'll discuss about it in a later slide. Containers also use Docker, use Kubernetes or any other container management service. Then containerize your application, package your application into containers so you can scale very easily. And maybe in your approach, I mean, you might not need DevOps in your initial prototype, but in DevOps, multiple uh, application instances can be deployed very easily. I mean, development, you have application development in one side, you have operations in one side, right? So application developers usually don't get involved with this infrastructure, routers, switches, network, security, etc. So you have operations people for that. But now development and operations are integrated together. And there, most of these things are automated. So we call them CI/CD, continuous integration, continuous delivery, right? You develop something fast and you integrate it to the application and you deliver it. Small components, small services, being delivered very fast. So pay attention to these DevOps concepts as well. Right. So some of these things I already explained. What are the advantages of cloud native applications? Accelerated delivery. I spoke about continuous integration, continuous development. So if you want to make a change to application, let's say now you are being evaluated in this competition, and maybe one person who's actually evaluating your application could ask to make a change. And if you have one monolithic application with a chunk of code, it will become very difficult to make that change. But in a cloud environment, if you have these microservices architectures, if you have containerized them properly, then you can actually make the change only in that small component without affecting the big application, right? So your delivery will become fast. So in the real world, let's say if a user wants to experience a new feature, then the company which develops the application can deliver that feature very fast without affecting the whole application, right? So your life becomes very easy. Then elastic scaling, depending on the requirement. Let's say if you take a clothing store. So in a clothing store, you know, usually in April and December, the sales, uh, I mean, the sales go high. I mean, because of the outdoor season and Christmas festivals and everything, in April and December, your sales go up. But let's say you have an online clothing store. In this online clothing store, so you decide to implement that online clothing store application, let's say a website or something, in your environment. So you buy the servers, you buy everything, and you have the application in your environment. Then suddenly, so you implement that in January, then suddenly in April, there's a spike in user access to that online clothing store. But you have not accounted for that, and you will not be able to serve the customers because you have your application is only using the hardware resources that you have paid for initially. You can't scale up. But let's say if you actually account for that spike or rise in usage and size the hardware accordingly, you buy a lot of resources initially, but you are only utilizing those resources in April and December. In January, February, and in other months, you are not properly utilizing the hardware that you buy. So your money is wasted. Your overhead becomes very high. So in cloud environment, depending on the usage, depending on the access levels, you can dynamically scale up or scale down. And you are only paying for what you use. So if there's a high usage, then your cloud environment will automatically scale up. If your usage goes down, then it will scale down. So we'll only pay for the spike. You don't have to waste money unnecessarily. Then resiliency, if something happens to an application, you have backups. They will you can use those backups, and most of the systems are self-healing as well. And if something happens, you can, I mean, if you have configured it properly, if something happens to one application instance, you can take remediative actions and get the other applications up. So you don't have to manually get involved. These things will happen automatically. Right. So optimization I spoke about. So I will not go into explain that again. So I'm actually using a very simple language and to explain the concepts properly to you. So I'm not trying to go into deep technical concepts, but if you want to know more about these technical concepts, please feel free to put them in the chat. Right. So I spoke about monolithic and cloud native applications. So monolithic applications, big chunk of code, single deployment unit. You implement the application holistically. One implementation. Components are very tightly coupled. If you want to make a change to one component, it becomes very, very difficult because the change will affect everything else. Sometimes if you want to update an application, then you have to take a downtime and update the entire application at once. initially it's less complex because you are only developing one application. And these, I mean, with microservices, there are multiple integrations, and I mean, different things that you have to consider. But in monolithic architecture, it's at the initial levels, it's not that complex, simple development. But with changes, with customizations in the long run, it becomes very difficult. Monolithic applications can't be scaled uh, flexibly because uh, it's difficult, because in a microservices architecture you can add microservices whenever you want. You can make changes to the application design easily. But in a monolithic environment, it's difficult, and even based on the usage or anything, you can't scale up easily. And monolithic architectures mainly have single technology stack. So whatever the technology stack that you decide to use initially will have to be maintained. In cloud native environments, it's a distributed architecture, different components of the application running in different places, in different environments. It could have different technologies, different frameworks, etc. Scaling up is very easy. You can implement a new function or a new feature easily without affecting the whole application. And resilience is high. Components are loosely coupled. That means you are free to move around. You are free to move around. You take one component from here and you take another component out. You plug this in. It's very easy, right? And there's something called polyglot technology options as well. That means you can use different technologies, different coding languages, different frameworks within one application. One microservice can be in one language, other microservice can be in another language. Very easy. Right. These things I have already discussed, so I will not go through it again. So I explained microservices, containerization, service mesh, and orchestration. Orchestration means, so if you, I mean, in bands and all, we have, I mean, like, do you know about orchestras? Where this large group play different music instruments and everything. So there's a person who actually coordinates everything, right? So in the same way, cloud platforms can be orchestrated very easily. You have a single console, everything can be orchestrated, managed very easily, and you can automate most of the tasks. Containerization, I spoke about. Microservices, you already know. Service mesh is the infrastructure communication layer that you have to facilitate communication between different microservices. There are different service providers like Istio or Lincoln, which actually provide service to service communication. And they do, traffic control, encryption, security, monitoring, observability. Observability means you observe the application in production environment. Who's accessing, what are the resources being used. These things can be observed. So service mesh will provide those as well. So when you are running your application in AWS, Azure, Google, so you will use these things. I mean, like, you will have to use these things to get an idea about the application usage, what are the issues which are happening, what are the error messages you are getting, and what are the security threats, what are the, I mean, all the problems, everything can be seen in your cloud platform using these service mesh concepts. Right. So this is a typical microservices architecture. So let's say a client could be accessing your application using a PC, um, over a mobile, using a web browser, right? Or maybe you have an instance in your mobile. You implement the application in your mobile, and the backend service can be hosted in your cloud environment, right? Or maybe you will access the application only using a web browser. So you have to decide that depending on the application architecture that you have, whether you are going to develop a mobile application, whether you are going to have a client service architecture where you have a client in your laptop or PC or mobile and access the server in backend, or you are going to access the application using a web browser only. That's up to you to decide. And so load balancers are basically used to balance the load between multiple instances. You will not need it initially because your requirements will be low, but you are expanding the application, then you will need a load balancer in future. And there are API gateways as well, different domains based on your design architecture. And within a single domain, you will have different services. So here you have service A1, service A2, service A3, different microservices, right? And these microservices will connect to backend databases as well. So one application having different microservices. So let's have a look at an example. So this is a web application for a online store. So when you log into the online store, you put your username and password. So you have your own account. Then, so that account will be managed by, so this is a simple example. Not all the online store applications are like this. This is a simple example to give you an idea about the microservices architectures. So this account service will be provided by the account microservice, and it will connect to maybe a database which is having your usernames, email addresses, home addresses, and other data, right? Then the online store will have to manage an inventory. Then one microservice can be dedicated to inventory management, right? Then there's a, I mean, like when you click on different items to buy, so if you go to Amazon or eBay or whatever, when you add items, they go to your shopping cart, right? So this shopping cart can be managed by a different microservice. Then when you are checking off, you have to pay. There should be a payment microservice, right? And once everything is done, you should get the goods, right? Then they will have to ship it. Then that entire shipping management thing or logistic management thing can be done using a shipping service, shipping microservice. So like that, different services can be uh, implemented using microservices. So if you want to make a change to the way you ship, then you only need to make a change to this shipping microservice. And if you want to add a new payment service provider, then you only want to make a change to this payment microservice without affecting the entire application, right? Okay, I spoke about containers before. So this diagram will give you a good idea. So in the right-hand side, you have the traditional virtual machines. You have the infrastructure. On top of that, you have the hypervisor or the middle layer, which actually virtualizes the infrastructure. Then you have different virtual machines. Machine A, machine B, machine C, which have their own guest operating systems. And on that guest operating system, you implement a particular application with other libraries and dependencies, etc. But in the left-hand side, you have the containerized architecture. You have the infrastructure, and on that infrastructure, you have the host operating system. In a laptop or PC, you have your Windows or Linux or Solaris or whatever. And on that host operating system, you implement the Docker platform. And the Docker platform will actually help you to have multiple containers. So within one application, so in a container is something which has all the dependencies in sense like libraries and everything, their dependencies and applications inside. So you can take one container from one environment and put it in another environment and run it very easily without changing much. So most of the large applications now are actually based on microservices and containerized architectures. Right. So then cloud services are actually cloud applications are mostly event driven. Sometimes your design may be different depending on the problem or the application architecture that you have. But in cloud applications, we have these event driven architectures. That means when something happens, it will actually create an event. right? So let's say you upload a picture to, let's say, a website. So you upload a picture to a website. Let's say YouTube. You upload a video to YouTube, and YouTube will automatically create a thumbnail for that YouTube video, right? That means when you upload the video, there will be an event, and based on that event, YouTube will trigger some other services, and thumbnail will be automatically created, right? So these events, I mean, when you produce an event, these events will actually trigger other actions as well. There will be a state change, then it will trigger other actions. So when an event is created, there's something called an event bus, which will route these events to interested consumers. Who are these consumers? Consumers mean other applications or resources which will actually make that event to do something. Right? So in new application as well. So let's say if a user wants to get something done, they will start a process. They will do something in the application, and it will create an event automatically, and that event should be transported to other consumers who are expecting that event. Then for that, we will use an event bus. But in your cloud environment, I mean, you can actually get this fully automated. You don't have to worry about these things because cloud service provider will give these services to you. Then you can define the event consumers who are going to make use of that event, right? Then let's say in AWS, we have something called S3 buckets, storage. So we have something called S3 buckets, and in these S3 buckets, you can host websites as well, and also you can upload pictures or videos or whatever. So if you upload a picture to a S3 storage in AWS, and if you want to create a thumbnail out of it as soon as you upload the picture, you can call another function. In AWS, functions are called Lambda. These serverless instances I spoke about. So if you have created the function, then when you upload the image to your S3 bucket, an event will be created, and it will call that Lambda function, and a thumbnail will be automatically created. And also, there are event stores as well, which will have all your events stored, history of all events. Sometimes, I mean, let's say if you want to do a root cause analysis to identify an issue in your application, then what happens is you need to dig down. So you need to see everything that happened within your application. Then you will have an audit trail as well. It will have all the events with dates and times and everything. So in the same way, all the events in an application can be stored for future use as well. Right. So I briefly touched upon this when I was explaining the previous content, how you want to identify the problem statement, how you want to plan and do the design, the application architecture that you have, that you want to have, and what are the limitations, what are the boundaries, what are the dependencies, and different models, what kind of microservices you are going to use, what kind of containers you will have to have, and what are the other third-party service providers you need to integrate with, and how you are going to integrate with them. So all these things, and how you are going to test the application, what are the testing mechanisms you are going to have, and what's your method for deployment, and what's your plan for that. So everything needs to be properly discussed, documented, and kept for future usage. So maybe your marking scheme has an allocation to give marks for all these aspects. And also one thing you need to take into account is that when you are developing the application, you should implement controls for auditing and monitoring at each step. If you don't have those controls identified, then debugging and identifying a problem will be very, very difficult. So in our AWS, Google, or Azure environment, sometimes you need to manually turn on all these monitoring criteria. Sometimes they will not be automatic. So if you have not turned on these monitoring aspects, then you will not see the logs properly. Then tracing will be very difficult, and you will not see the application performance matrices as well. So make sure that you have a good idea about how you are going to monitor your application. Otherwise, you will not be able to troubleshoot or identify an issue. So let's say you are doing a demo of your application to the judge panel, and something happens. If you have not turned on logging and monitoring, then you will not be able to identify the issue properly. So make sure that you pay attention to that. Right. Then containerization with Docker. So there are free desktop Docker versions that you can get. Make sure that you play with them. So I'm not going to go into detail on that. You can go through the slide later. But in Docker, you need to create a basic image with all the dependencies, application codes, libraries, etc. And once that image is properly built, you can test them locally. So get help from a professional developer when it comes to, so if you are going to use containers or Docker instances in your application, get help from a professional developer. Or if you want, I'm sure the organizers have a plan to provide support and help whenever necessary. But do these things: image building, testing, using using container registries like ECR or GCR. ECR is Amazon's container registry, and GCR is Google Cloud's container registry. So play with these concepts, play with these environments if you plan to use containers in your application. Right. In Kubernetes, there are few fundamentals you need to know. We have something called pods. A pod is the smallest deployable unit. So let's say in one pod you can have one container or multiple containers, right? Depending on how you design it. So you can have one application, one big requirement pod with multiple containers, so maybe one container. So in your application design architecture, see whether you need to have pods or maybe multiple pods as an option. Then you deploy the Kubernetes. Using Kubernetes, you deploy these containers, and when you, like we call it declarative updates. I mean, once you deploy, everything can be automated using your cloud environment. I mean, without having to manually interfere, you can, using the CI/CD services they provide, you can automate most of these things. I mean, don't think hard if you don't understand these concepts, because you might not want these things in your prototype anyway. So just have a look at these things once I share the slide deck. Right. This one also I will skip for the moment because I have explained these things. If you want to play with Docker, if you want to play with containers, use Docker Desktop. So it will help you to run containers locally. It has a graphical user interface as well, and so we can actually play with containers and Kubernetes integrations, Docker integrations using Docker Desktop. Then there's something called Minikube as well. It has a local Kubernetes cluster for development and testing. Get access to that and maybe try it out. Then we have VS Code extensions, which actually enhances productivity with Docker and Kubernetes tools. It can help you with the remote container development, YAML validation, etc. So YAML is very simple to use. It's like a human language, a structured human language, which can be used to provide the instructions, uh, software development, and mostly infrastructure as service as well. So use these tools, download them, play with them when you are developing the application. So before starting any development, make sure that you have a very good understanding about all the technologies that you are going to use. So almost all the cloud service providers have free courses for you to get certified. Right. Then we have infrastructure as code. We have Terraform, we have AWS Cloud Formation, and we have Pulumi. So these things can be used to deploy infrastructure. I mean, what do we mean by infrastructure? Servers, network devices, routers, switches, databases, everything, right? So earlier, what we used to do was that when we need to deploy an application, we have to manually select, configure, and integrate infrastructure, which was difficult and time consuming. But right now, actually, you can develop a code and provide instructions to your environment to get all the resources connected, integrated, and implemented in a very easy way. You don't have to worry and focus on these infrastructure deployments because of these infrastructure as a code services. You can focus on application development and application functionality. So if you use Terraform, so it has a declarative language for provisioning infrastructure. It's a complete ecosystem which manages different states and everything. You can plan and apply workflows, and also it supports multi-cloud environment. Then similar to AWS CloudFormation, other service providers have their own technologies as well. It's a template-based infrastructure provisioning. So if you are using your application in AWS, then you can use AWS CloudFormation. Right? In the same way, in Azure and Google also, they have their own services. Then if you are using Pulumi, then you can have multiple language support like Python and C Sharp and a few others. So using those things, you have a flexibility to define your uh, code. I mean, infrastructure as a code, IACs. Right. So use these tools and get an understanding. Also, Pulumi supports policy as a code as well. I mean, like compliance policies, security policies, etc., can be defined using Pulumi. So see whether you need to use infrastructure as code concept. Maybe since you are developing an initial prototype, you might not need that, but you can actually have infrastructure as code as well. Right. So the following slides, I don't have to basically go through. They just provide comparisons between different cloud options like Google, Azure, and AWS. So all the service providers will give you a lot of resources, similar resources, depending on your choice, experience, skill level, and just out of pure interest, you can define which service provider you need to use for your application, right? So this is a very simple comparison of different services. I mean, this is not an exhaustive list. I just wanted to let you know that all the service providers have mostly have what you desire, right? If you want to, let's say, use serverless function in AWS, then it's called Lambda. In Azure, it's called function. In GCP, it's called cloud functions, right? If we want to use platform as service, then AWS has Elastic Beanstalk, Azure has App Services, GCP has App Engine. So different names, but mostly the same concepts. So I mean, like, mostly when it comes to cloud services, we get access to computing service, we get access to storage, networking, and databases in most of the environments. So different names, similar concepts. So this slide covers the AWS cloud services, which I will not go into detail, but make sure that you are using the right resource. You don't have to use a serverless function if it's not needed. You don't have to use containers if it's not needed initially for your prototype. So don't get your life complicated. Don't go with complex architectures initially. Have a simple architecture which can be expanded. And storage, so S3 has advantages and also limitations. Same with block storage, or same with EFS as well. So study these concepts, go through the courses, go through the material, and decide what you are going to use. So same in Azure, different name, same concept, same services. Google, same thing. So use what's familiar to you, what can be used easily. Right. Then database selection is very important. So if you want to select a database, so make sure that you select the right database for your application. So mainly we have three types of databases. We have relational databases, which are basically used for structured data. Using SQL, and structured relational databases help you with ACID principles as well. That means, like, let's say if you are going to do a banking transaction. So this banking transaction, so let's say you transfer money from one account to another account, right? So when you execute that transaction, so money will be reduced from your account and the other person's account will be updated. So there's a process for that, right? There's a process for that. So everything should happen in a structured way, step by step, and security, consistency, isolation should be there. So that's what is meant by ACID compliance. So in relation databases, it's very easy to achieve that. And complex transactions can be executed. And there are no SQL databases as well, mostly for unstructured data. Right? In AWS, you have DynamoDB. So let's say if you are dealing with IoT devices, and if you are dealing with streaming devices, then, and if you are if you are analyzing user characteristics, like user profiles or something, then most data are unstructured. So data that you get from IoT devices are unstructured, right? And if you are developing an application like that, then maybe you need to go ahead with the NoSQL database, right? And there are in-memory databases as well, like Elasticache in AWS. That means your response time will be very high. Your latency will be low. Let's say if your application need very fast analytics done, very fast response times, then you might need to go with the in-memory database. And if you want to cache certain things, then an in-memory database will be useful. And also, your application could have multiple database instances as well. You could have relational database for one purpose. You could have in-memory database for one purpose, or maybe no SQL database for one purpose within the same application for different purposes. So different microservices can be using one or multiple instances of these three areas. So identify the requirement and then choose which database you need to have for different functionalities. Right. So serverless architecture, I explained how it's done, how it's similar to a function. You call the function. It is basically event triggered. You create an event, then the function will be called and it will execute something. Then that function will go out. And you are only paying for the function usage. Everything, database, storage, and other infrastructure, third-party APIs or connections, everything will be managed by the cloud service provider. So you only focus on the function, you define what you want to get done, and depending on what you define in the function, everything else will be automated and managed by the cloud service provider. So that's how a serverless architecture works. Right. So your application should support auto scaling. You can enable auto scaling very easily in your cloud environments. That means, so I explained it using the online clothing store example. Depending on the usage, depending on the access levels, depending on the spikes, your application will automatically scale up or scale down. Then, if you are experiencing a lot of traffic for your application, then you may need to load balance between multiple instances. Then you can use a balancer. Then that load balancer will distribute traffic among your multiple instances of applications, maybe equally, or maybe in a round robin way, or maybe according to different weightages you define, depending on application design and architecture. Also, if you are using AWS or Azure or whatever, then you can have multi-region deployments as well. You can have one instance in one region, let's say Europe, another instance in North America or whatever. So geographic redundancy can be achieved, and this is sometimes important for disaster recovery. So if you are if the the whole of Europe goes down, I mean, not the country, I mean, the cloud environment goes down, but you will still have access to whatever you have in North America region. I mean, very unlikely, but if something happens, you still have access. And also, in large applications, if something happens to one part of the application, then that could be propagated to the entire application or other areas of the application, or maybe to the entire integrated services. So for that, you have something called circuit breakers. I mean, like similar to what you have in your homes. So if something happens, the circuit breakers would go off, and it will prevent cascading of certain failures as well. Right. CI/CD, I basically explain what CI/CD is. That means continuous integration and continuous develop. You create a code, and I mean, this can be automated. You create the code, then containers will be automatically created, deployed, tested. There are tools that you can actually use. So mainly, I believe that most of you would be working with the GitHub as a code repository. So you can push and pull codes. You have access to GitHub. You store all the codes there, and GitHub has something called GitHub Actions, which tightly integrates with GitHub, and so GitHub plus GitHub Actions will give you a full code repository and CI/CD environment, DevOps environment, right? In similar way, we have something called GitLab CI as well. So GitLab CI has a single um, environment to host code and have an integrated DevOps platform. Right? So it has built-in security scanning and other functions as well. So either you can use GitHub with GitHub Actions, or you can go to GitLab CI as well. Then you have Jenkins. So if you want to use traditional applications with a modern application environment, then maybe you can use Jenkins, right? So different tools for different purposes. So for your application, see whether you want to go ahead with GitLab, or whether you want to go ahead with the GitHub and GitHub Actions, depending on your requirement. Right. There are different deployment strategies as well when you are going to put your prototype into production. There's something called blue-green deployment. That means having two identical environments of the same application or like, let's say the same production, then you can switch between these environments and switch traffic instantly from an old version to a new version. So without having big downtime, mostly zero downtime. And if you make a change to application, if something happens, then you can roll back easily. So keep that in mind. Keep that in your mind as well. So in this competition, when you are developing the application, you will be making a lot of changes. And if something happens, you need to roll it back. So keep that in mind. Pay attention to how we are going to roll back. Right. Then we have something called canary deployment, where you release the application to a small subset of users first, and depending on their feedback and everything, you make changes and make the application perfect. Right. And that's also a method. I mean, like for your prototype, you can find a set of people you are going to test the application with, and based on their feedback, you can make changes. Then we have something called rolling deployments as well. I mean, basically that's actually replacing one instance by another instance to have to achieve a balance between stability and how we are going to speed up the update, etc. So that's also a methodology. See what you are going to do. But one thing I want to highlight again is that make sure that you can roll back whatever you do if it's required. If it's required. Right. Then I spoke about security. Security is very important. Um, I spoke about identity and access management, how we are going to access the environment, what authorization levels you are going to use, how we are going to authenticate, how we are going to do accounting. That means logging everything, automated logging for auditing purposes, for root cause analysis, etc., and problem identification. Then for APIs, you have secrets. For encryption, you have secrets. How are you going to manage those secrets? What are the services that you are going to use? And if you are into DevSecOps, DevOps, then focus on security as well. Now we call it DevSecOps because development, security, and operations are tightly coupled and integrated with each other. So DevSecOps is a good field to be in, and good DevSecOps engineers are highly paid. Maybe a career you might want to have in future. Then focus on compliance. Let's say now Sri Lanka has something called Personal Data Protection Act. So if your application is going to use personal data, I explained earlier, make sure that your application is properly compliant. And if by any chance you are going to give this application to, let's say, European users or maybe users in other uh, countries, make sure that you are compliant with data protection laws and regulations in those countries. If you are going to, if a European user is using your application, then your application needs to be GDPR compliant. Else, if something happens, the repercussions will be very, very bad. And so make sure that these compliance requirements are addressed. The cloud security best practices, we have something called defense in depth. That means having multiple layers of security. So you can have perimeter security like a firewall in your cloud environment. And, if you maybe depending on the application, you need to have another web application firewall as well, database firewall, or maybe an endpoint security for your virtual machine, or maybe you will not need it initially, but if the application is very large, then there are denial of service protections, data loss prevention solutions, then other web traffic analysis solutions. So these are some of the things that you need to integrate in your architecture. Then you have something called zero trust to verify who's accessing your application. We call it never trust, always verify. So if someone is trying to enter into your house at 12 o'clock in night, then you pay more attention. If you hear a knock on your door at night at 12 o'clock, then you panic and you pay more attention. If you hear a knock at maybe 12 in the daytime, then your attention will be low, right? So in the same way, in the zero trust model, depending on depending on different scenarios, different parameters, and different contexts, you can allow people allow access. You can deny access. You can control access. Dynamic things. Always verifying who's accessing, what's the application they are using to access, which resource they are accessing, what's the access method. So there are multiple things you analyze. Then continuous monitoring, I spoke about it. Implement monitoring controls in your application and use patch management, use the proper updated libraries. If you are managing the operating system, make sure that patches are implemented. So these are few basic things you need to pay attention to. Observability and monitoring, I spoke about monitoring. Turn on alerts, turn on logging, turn on whatever the tracing options you have, turn on and configure matrices and gather performance data and production data and analyze them to identify how your application performs and to make remediation actions to any issue that you have. Right. Then one area where you can go wrong. So when you are using cloud platforms, if I'm not mistaken, most of these cloud platforms ask for a credit card. So I don't know whether it's the same thing in all the instances, but most of the time they ask for a credit card. So what happens is when you are using cloud services, sometimes you forget and sometimes you use unwanted services and you keep the service on. And when you keep the service on, then your financial clock starts ticking. And sometimes people actually mistakenly keep these things on and they get charged thousands of dollars. So make sure that you take the services or virtual machines or whatever down when they are not required. And use the free services, pay attention to understand how you are charged, when you are charged, and I mean, if you do certain things, you might not get charged. If you do certain things, you will be charged even when you are using the same service. So read and understand these things and also set a budget limitation. So when you have a budget, when you have set a budget, when you reach that budget, there will be automatical reminders, so alerts generated. So then you know what you are doing. So keep that in mind when you are using cloud. Then let's say what resource you are going to use. What are the virtual machines you need to have? What are the storage types you need to have? What are the processors you need to have? What are the operating systems you need to have? So all these things will have a play in your application design and cost and operational aspects. When you are going to use auto scaling and how you are going to use auto scaling, what are the triggers, the storage. So we have S3 storage in AWS, then we have other storage options as well. So you use one storage option initially, and with time you move from one storage option to another storage option. You rotate the data around. Let's say in your production environment will have one storage. Then with time you will move certain data to a data archive. Then this data archive will have other storage options. So have those things in your application design as well. So these are some of the resources that you can actually use. Documentation, read the documentation properly. Without reading the documentation, you will not be able to do the right thing. So all the service providers, even Kubernetes or other sites will have documentation. Use those things. Register for online courses. AWS has free courses like AWS Fundamentals, and you can even get certified as well. Then Google has free courses. Azure has free courses. There are service providers like Cloud Guru, Pluralsight, Coursera, edX. I'm sure you are using these things. Register for these free courses and study properly. And there are some interactive learning slides, learning environments, categorized, not there anymore, but you can still get access to the scenarios. Do practical experiments, implement these things in your school labs or laptops or PCs, play with them, play with Docker, play with Kubernetes, and without that, you will not be able to learn. Right. So I spoke about this as well, so will not go ahead with it. So these things also I explained. Right. So in testing your application, make sure that you test the application properly. So you might need to test the application holistically, end to end. Then maybe you need to do integration testing as well to see whether different application components are integrated properly. And if you do a change to application, you might need to do testing after that change to see whether everything works properly. And there are certain things like stress testing, security testing, regression testing, etc. So do those things wisely. Test and validate each component of your application, and because like you will not be able to identify the performance levels or issues if you don't test them properly. So don't deploy anything without testing, right? Test and validate before integrating and deploying anything. That's a must. Then, I mean, this thing will come to play if the traffic levels are very high and if you are implementing a large application. But let's say now, when I speak about it in my AI section as well, but let's say sometimes you might need to use caching to optimize the performance of your application. Let's say you, uh, let's say when you are accessing website, when you access the same website multiple times, then your bandwidth consumption will go high and you'll have to wait until things get loaded. So what happens is usually these websites are cached in your laptop or PC or whatever, maybe within your application. The same way, you can use caching in your application to cache certain information and data. That will speed up the application execution and performance. There could be multi-level caching implemented as well, right? Then optimize your databases, how you are going to use replicas, backups, whether you are going to have sharding. That means sharding is like having small pieces of data without having, like you create small chunks of data, shards without using it as a big, huge database. How you are going to how you are going to query the database to get the maximum out of it, how you are going to get access to information, how you are going to, whether you are going to have synchronous processing or asynchronous processing, how you are going to offload operations, I mean, resource intensive operations to the background workers, how you are going to route traffic. So these things need to be addressed when the application is developed to improve the performance and maybe sometimes reduce cost as well. If you cache data properly, then you can actually reduce the cost for API calls. So pay attention to the balance between cost and operation. Then there are different API design options, like whether you are going to use RESTful APIs or any other service. So since the time is limited, I'll skip this. But there are different APIs options that you can actually use. I spoke about this, how you have to choose the cloud background depending on the application design or the skill level that you have. Uh, Discuss with your team, identify the skill levels, knowledge levels, experience levels, etc. And based on that, try to define the architecture of the application. Right. These are some of the matrices, how the performance of applications will be improved if you are using cloud platforms. Key takeaways, think cloud native from day one, start small, scale smart, keep the future in mind. Imagine a startup that you are going to have on your own and develop the application and design the application with that in mind. Automate everything that you can. Don't waste your time doing manual things. If the task is repetitive, then automate it. No need to do the same thing again and again. And create a culture within your team to embrace these new technologies and practices. So that's the advice I can give you. I spoke about few resources. Learn the fundamentals and technologies first. Without learning them first, it will be difficult to implement. So anyways, you will be developing a prototype, I believe. And yeah, so it's not that hard. If you are in LinkedIn, you can connect with me, and so you can scan this QR code and connect with me, and I can help you guys whenever needed, or find me by name and connect with me as well. Or if you want to get any help, maybe you can get the email address from the organizers and write to me as well. Right. So actually, it took more time than I anticipated. So there's another section for AI. Let me quickly see whether we have. Okay, so it actually took more time than I expected. So what I'll do is, Kavin, can we do the AI session maybe on another day? Uh, Okay, yeah, it's there. So I'll do the AI session on another day. I'm sorry, it took more time than I anticipated. So and I had to skip certain things as well. So I'll do the AI session on another day. So we'll let you know the new date and time as soon as possible. Thank you very much for being here, and wish you all the best and good luck for the competition. And if you have anything, just get my contact details uh, from the organizers and reach out. I'll be more than happy to help you in whichever way I can. Have a good night and enjoy school on Monday tomorrow. Thank you, and see you later.
Good evening, everyone. As it comes to the end of today's session, I would like to extend our sincere gratitude to all of you for being a part of this insightful cloud and AI session of TesserX under the Axis 2025 initiative. A special thanks goes to our esteemed speaker, Mr. Neranjan Dissanayake, Chief Executive Officer at Just-in-Time Group, for conducting this session. Your expertise and forward-looking perspective on cloud infrastructure have added immense value to this session. To our participants, your active presence and curiosity continue to drive the purpose of this initiative. We hope today's session has enriched your understanding and will serve as a valuable asset in both your academic and professional journey. We are also grateful to the All Royalist Engineering Professionals Association, whose commitment to nurturing future innovators is truly commendable. Thank you once again, and we look forward to see you at the upcoming sessions.